Today we're going to take a quick tour of the TestifySecs platform. There's two main concepts in the platform that we'll discuss today. The first is the idea of products. So a product is the thing that you want subject to a particular compliance framework. So when we think of the types of compliance frameworks that you may want to apply, think of things like FedRAMP or being able to prove compliance with things like the SSDF, the Secure Software Development Framework. And when you deliver a product to a customer, the thing that you're going to be selling or the thing that's going to be expected to be in compliance is not just a single source code repository. It's not just a single container image that gets built. It's the collection of all of those things. So most of you probably deliver products that are composed of multiple different microservices. If you're delivering a SaaS application, it includes the infrastructure, the deployments, the configuration of the clusters that are actually running the application. And so a product is intended to capture that. Today, we have a pretty simple demo product. It consists of a single Git repository, in this case, TestifySecs/SWF. And this repo is actually open source. If you want to go out and visit our GitHub page, you can see this repository and all of the details that you're going to see behind the scenes here. And you can see currently we have no compliance frameworks assigned. And because there's no compliance frameworks, there's no controls. So let's next get into what exactly a compliance framework is. So we're going to go ahead and edit this product to assign John's release process. In this case, this is just the representation of an internal release process we want to be able to apply to this product to give our organization confidence the software we're shipping to our customers is up to the expectations and standards we really want to meet. In this case, we can see there are 8 different controls. And the 8 different controls in this consist of multiple different things, some that developers care about, some that the organization cares about, and some that are things that the compliance team cares about. So we can see these include things like secret scanning, generating an SBOM, formatting code, static analysis, a lot of these different things. So once this framework is applied to our product, a developer will have an instrumented pipeline. In this case, we use our open source project Witness in order to be able to observe this process. And so rather than running this pipeline itself, in the background here, I'll go ahead and upload this evidence. As I said, you can go out and actually find the links to all this evidence here. But you'll notice in this pipeline, it's the things the developers care about. It's formatting their code so it looks good in their IDE. It's vetting for common coding mistakes and things like that that they know they want to catch. Unit testing to give them confidence in the code that they're shipping. And then in the end, the obvious things, building a container image, building a binary to be able to test and use those things. So as we come back to our platform, we'll go ahead and look at what the compliance posture of this product looks like after the developers did what they normally do. In this case, we're not there yet. We're only meeting half of the controls, half of the expectations the organization has in order to ship this software to customers. So each of these controls are defined with things called directives. So in this case, we can see our static analysis directive is defined behind the scenes as the tool semgrep. And semgrep is what will help us meet as a directive the control of static analysis. Static analysis comes up in a lot of different compliance frameworks. NIST 853, SA 11 covers a whole bunch of different aspects of testing. So static analysis is one of those. The other thing you can do is specify multiple directives if there are multiple different types of tools that are allowed for static analysis. So we'll come back here into the product itself and we'll look at a different pipeline. This is a pipeline that we're working towards helping the organization define on its behalf. Rather than just asking you to go off and build this yourself, we understand which tools are allowed, which tools are required, what the options are when those tools are run in order to meet this. And then obviously to capture the evidence of those things being done. So in this case, we've implemented a pipeline that includes linting for container images in Kubernetes manifest to ensure that they meet the requirements like least privilege, making sure that none of the containers are running as root, static analysis against the source code, generating the SBOM, and performing a secret scan to make sure we're not shipping any secrets to customers that we don't want them to be able to have access to. So in the background, once again, I'll go ahead and upload that evidence, and then you can go out here to GitHub Actions and see the results of this job, all the different attestations that are created. So we'll come back here into our platform, refresh the screen again, and now we should be able to see we're actually complying with the entire compliance framework. We can see 8 out of the 8 controls are passing now. The other thing that you can see here in the background, we've been able to do a vulnerability scan. So if you think back to each of those workflows we saw, one from the developer team, one from the compliance team, there was no vulnerability scanning. In this case, our platform was actually able to do that when an SBOM was generated and uploaded to the platform. As each of these different pieces of evidence come into the platform, we can be aware of those. In this case, we execute a workflow on the back end that uses the open source tool Gripe in order to perform this vulnerability scanning. In the future, we can support other types of tooling. If you have a proprietary or enterprise grade vulnerability scanning service that's hosted somewhere in your organization, we could call out to that, or we could move any of these other jobs to be executed as workflows on the back end of the platform so other folks in your organization don't have to worry about that. So this is the overall view that we want to be able to offer to customers, being able to have products defined with multiple components that you apply compliance frameworks to so you can validate each of the controls are being met. Now, this is pretty simple, and it's supposed to be. But behind the scenes, there's a lot of things going on. We're going to give you a sneak peek of some of those. So down here, you can see for our repository, we have a set of evidence that was captured and uploaded. And you can view all of this evidence here corresponds to a single Git commit. So if we click on any of these pieces of evidence, we can see everything that is been captured for this Git commit. We can see the evidence of static analysis, the evidence of generating an SBOM, scanning for secrets. And if you want to as well, you can drill down into the level of details of every environmental variable that was captured. You can get down to system call traces. You can see the higher level things like an SBOM or a build provenance document that's generated. Information about the Git repository, so you can see if source code was modified in between these steps or before a job was run. Then you can also see information about the certificate, who signed this. In this case, we can see this was signed by SigStore. We're using the GitHub Actions workload identity in order to be able to do that. Now that we have all this information, we need to generate a policy. So in the back end, each of these controls with their directives map to a witness policy, which is one of our open source projects. So in this case, we'll go ahead and take a look at our HADOLint policy. And this is automatically generated by the platform. It helps you to understand and help you determine who you should trust to do these different things. We know that this is a GitHub repository, so we can trust in our organization, based on the rules we've defined, that we will allow SigStore signatures for the GitHub Actions workflows to be approved to provide evidence. And this is all present down in the raw JSON of the file, the policy file itself. So you can see here our linting job defined. We have expectation that a command run attestation, these are the different types of attestations you saw on the previous screen, and we embed rego in here. In this case, this rego is looking for an expected command. Since this is a static analysis tool, one of the common command line options for static analysis tools is -- ignore some rule. We don't want to allow this in our environment because those checks that the static analysis tool are doing are required in order to prove compliance. So it's not just enough to say we've run this tool, but also we've run this tool with the proper configuration. And then below here, you can see all the other metadata and information about who we should trust to perform these different types of operations. We're tying and coupling this trust specifically with the source code repository, with GitHub Actions, ensuring that it's a cloud-hosted runner and not a locally hosted runner that could be modified or manipulated in some way. And this is what happens and goes on in the background in order to show that your product really is in compliance with the requirements you have. So that's a quick tour of the TestifySecs platform, showing you how we define products, how we define compliance frameworks, and a little bit of a sneak peek at what goes on behind the scenes in order to help you ensure this and governance and compliance is proven within your organization. Thank you.